Now we are going into the last part of example 5, which looks like this. That is D. And D equal, okay, D equals what? Part D, okay? Y equals x to the x. That's it. This is what we're going to do with right now, okay? So let me erase the board for you, okay? Here we go. All right, here we go. Okay. All right, here we have y equals x to the x. Is it on the board? Good. Okay, can you all see that? Good. All right, that's y. Run big. Okay, here we go. How do I find the derivative of y? There we go. And I don't have the formula for this, Mr. Dan. A variable to a variable, I don't know. So what do I do now? Look, this is what logarithmic differentiation jumps right in. Can I take ln both sides? Okay, if you do the same thing to both sides from a perfect balance function, it is fine. Take ln to both sides. There we go. Is it on the radar? Good. There we go. So what is this now? Okay, can I bring this x down? Excellent. X times ln x. There we go. Okay, you see it? Good. From a very complicated, notice the powerful properties of logarithm. You see it, guys? There we go. I take ln both sides. I got down right here. Now, what am I looking for? Again, my goal is, Mr. Dan, I am looking for that right there, the derivative of y, of the function, okay? So here we go. Can now I take derivative. Now I take derivative both sides. Look, ln of u or ln of y derivative is y prime over y. Okay, you see it? This over here, now you can take derivative because a variable times with a variable, you can do the product rule, which is u times v. Got it? The derivative of x is 1 times with ln x. Got it? All right. Plus the derivative of ln x times with x. Derivative of ln x is x prime over x, which is 1 over x times with x itself. There we go. You see it, guys? Now, I am going to draw my board up here for you. Bring up here, you got, okay, what is this? X and x go into 1. So now I have y prime over y equals ln x plus 1. Okay, you see that? Now, all I do is just solving for y prime, bring y up here. So y prime now equals y times with ln x plus 1. That's it. But we're not done yet. You want to put, y prime all with respect to x. Technically, plug y equals x to the x itself. X to the x. That's what y is. Okay? Now, my solution is done. Done deal. Okay? You see it? Good. All right. We're done with example 5. Now, let's finish this section real quick. You see now the application of logarithmic and the basis other than e. It is a huge application for your compound interest as well as other real math model that bring into application as well. Okay, look with me in your application. You are no stranger to this formula right here, and you sometimes wonder, where do they come from, Mr. Dan? You have an a written in this form right here, 1 plus r over n, and the whole thing to the n power. Okay, this is the formula that you will see the annual interest with rate r, and you are no strangers to this guy right here. Now, this right now, when you apply the properties of a limit involving e, look, when times, or how about when x run to infinity, and you have this form right here. This is a beautiful form from Mr. Euclid. Okay, this right here is equivalent to the limit of, okay, x going to infinity, okay, and then you have x plus 1 over x right there. You see it, guys? Okay. To the x power, what does that equal? That will give you e right there. Okay, you see it? Apply these properties, plug it back right here. This I will, when we have some time or when we zoom in, I will prove that for you. It's a beautiful, the proof is right there, just a few lines on the bottom of the theorem 5.15. This now, take this into P e to the r. That's it. From these properties, apply that. This one is being simplified by that right there. Okay? And because of this right now, as your annual interest with rate R, you are coming into a compound interest formulas, which is you want to invest in your interest of, let's say, every quarter or every month, or you want to do it continuously, month after month or year after year. This now you have two famous formula in economy or in economic model. And I will just briefly go over this because technically we are done with 5.5. Here is our agenda and part A. Okay, remember, look at the summary of compound interest formulas. You will see two compound with n times per year, or it is invested continuously. You have two formula. A equals P1 plus R over N and all the way to NT. Guys, we did this already in algebra, okay? And then the second one is you have A equals P e to the RT. What is the difference between these two, Mr. Deng? You know more than I do. You guys deal with business and you understand more than Mr. Deng right here. This is when you deal with the compounded quarterly, every quarterly the interest. This one keeps going, which means that you do it continuously. And then the R stand for the rate of interest. T stand for the time. If months in the year, you got 12. If every quarter in the year, you got T equals 4. Apply this, you will see example 6 come out pretty clear, and I will not waste time here with you, okay? So you know that well. Look at example 6, and it's self-explanatory for you. I am moving into example 7 because it's more calculus for us. Example 7. Example 7 right now you have a, oh boy, talking of virus. We have bacterial culture is growing according to a logistic growth function. Logistic growth function, you have y equals, this is the model of certain bacteria, 1 plus right here is 0.25 e to the negative 0.4, I think t. There we go. And they gave you a condition that t, right here, t is bigger than or equals to 0. Start with, times 0. So when t is 0, you plug it in. When t is 0, you plug in. This is right. There we go. Okay, you guys see it? When t is 0, plug it in. 0 times that give you 0. E to the 0 is 1. 1 times that is 0.25. Plus 1 divided by that, you will got y equals what? Y will be equal to, when t0, you got, 1 over 25 or 1, 1. When if t is 1, which is the year is 1, what do we have? The bacteria grow right, the weight of that, which is plug in. T is plug in 1 right there, what you get? Okay, you get 1.071 grams, okay? Now, what if t is 10? Plug in, you will get some result too. Here is the big question, okay? This is a big question. Mr. Deng, what if t keep going and going into infinity? If t is going to infinity, what would be the bacterial growth right here, Mr. Deng? Look, if t goes into infinity, look right here. If t is going to infinity, t go to infinity. All right, that times with what? Infinity. You got infinity time with a negative number. So you got a negative infinity. And e to the negative infinity, meaning e to the negative infinity, 1 over e to infinity. And 1 over e to the infinity, that would give you 0 because very small number. So this guy go to 0. Okay, this guys go to 0. And then you got the denominator is 1 over 25. That's how you get y equals 1 over 25. Ta-da! Okay. What's the point here, Mr. Zhang? Meaning, based on the data, you will now set condition and you can just pick the best mathematical model that fits the situation of the bacterial culture when it grows over time. That's it, guys. And that concludes 5.5. Okay? Adios. See you next in 5.6.